Part A, 3 sine 5 theta. First thing we notice is the frequency is 5, which means that we have 5 cycles between 0 and 2 pi, which means that we have a cycle every 2 pi divided by 5 radians, which means that our tick marks that we make to split our period into sections of 4 is going to be 2 pi divided by 5 divided by 4, which ends up being 2 pi divided by 20, simplifies to pi over 10. So we say we have a tick mark of pi over 10. Oh boy. 2 pi over 10, which would simplify to pi over 5. 3 pi over 10. 4 pi over 10, which simplifies to 2 pi over 5, so that's one cycle. Then we have 5 pi over 10. 6 pi over 10. 7 pi over 10, and 8 pi over 10, which simplifies to 4 pi over 5, so that's 2 cycles. We notice that the amplitude of this is 3, so we should go up 1, 2, 3, down 1, 2, 3. Sine is the y value on the unit circle, and if you make an angle of 0, an input of 0, then the y value is going to be is going to be 0. So we start at 0. And then every one of these tick marks, we've now divided it up into each period into 4 sections, so now we can hit the major values that sine goes through. So at pi over 10, we're going to jump up to the max at 3, 2 pi over 10 back to 0, 3 pi over 10 to negative 3, 4 pi over 10 back to 0, there's one cycle, 5 pi over 10 back to 1, 6 pi over 10 back to 0, 7 pi over 10 back down to negative 3, 8 pi over 10 back to 0, and now we just have to connect the dots, which I will do, oh my gosh, do my best. Here we go. It's really hard to draw on this iPad. Not so bad. Okay, there we go. There's one cycle. There's 2 cycles of 3 sine 5 theta. Okay, negative 2 cosine pi theta. So we have a frequency of pi, mixing it up a little bit. So then our period is going to be 2 pi divided by the frequency, which is pi, which means our period is 2, which means our tick marks are going to be 2 over 4, which is 1/2, right? So I'll write that as 0.5. So our first tick mark, 0.5. Second tick mark is 1. Third tick mark, 1.5. 2, 2.5. 3, 3.5. 4. Amplitude of negative 2. So normally on our circle, cosine with an input of 0 starts at the max amplitude, which would be which is negative 2, right? So at an input of 0, we're going to be down at negative 2, and then we're just going to cycle through our values. So we're at negative 2. At 0.5, we're back to 0. At 1, we're back up to 2. Back to 0. Okay, there's one cycle. And there's 2 cycles. Let's connect our dots. Okay, 2 full cycles of negative 2 cosine pi theta. Next we have cosine of 6 theta. So we see that we have a frequency of 6, so our period is 2 pi divided by 6, which is pi over 3. Our tick marks are going to be pi over 3 divided by 4, which is pi over 12. So we have pi over 12, 2 pi over 12, which would simplify to pi over 6, 3 pi over 12, 4 pi over 12, there's pi over 3, there's one cycle, 5 pi over 12, so 4 pi over 12, 6 pi over 12, 7 pi over 12, and 8 pi over 12. All right, and we have an amplitude of just 1 here, so 1, negative 1. Cosine starts up at an angle of 0. We have an output of 1. Okay, and then we're just going to cycle through. There's one cycle. There's 2 cycles. We're going to connect the dots. You should do a better job of this with a pencil and paper than I'm doing on this iPad, obviously. Okay. All right, last one. Negative 3 sine pi over 2 theta. So again, the frequency is pi over 2, so the period is going to be 2 pi divided by 2, which is going to simplify to 4. So that's easy. Our tick marks are just going to be 1. 4 divided by 4 is 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. Notice that our amplitude is -3, so we're going to start down, or we're going to start at 0, but then we're going to jump down to -3, back to 0, up to +3, 0, -3, 0, +3, back to 0. Connect the dots. Okay. So notice my graph's not perfect, but as long as you have the tick marks labeled and you have the correct amplitude, then you will be okay. You need to have the correct outputs at the correct tick mark. You need to have your tick marks labeled, and you need to have the correct amplitude. If your graph doesn't look perfect other than that, you will still get full credit. So another thing to notice is, like, when we look at this picture we've drawn, this looks like a normal sine curve, but remember, this high frequency is actually a squish sine curve. It's just because of the scale we've drawn with that it looks normal. But remember, normally our sine curve goes between 0 and 2 pi, and we're not even to pi yet when we have 2 cycles of this, right? We're at just 8 pi over 10, so we're not even to pi. So if we were to make our scale, if we were to sketch this from 0 to 2 pi and keep it on a normal scale, it would look really squeezed in, okay, high frequency. All right, that's all I got.